So if you remember, in Module 5, what we have left is instance-based learning. Instance-based learning. So let's define this. So when you hear the word instance-based learning, what we're actually talking about is these are sets of learning methods. Instance-based learning, okay? They are what? Learning methods that simply store the what? Training examples in contrast to learning methods that construct a general, explicit description of the target what? Function when training examples are provided. Now, generalizing beyond these examples is postponed until a new instance are to be classified. Okay? Now, whenever a new query a new instance is encountered, or whenever you encounter a new query, now it's relatively easy, right, to get back to the what previous instance, and then based on that, you now classify that to the target function. Now, what we know in this method, we say that instance-based methods are sometimes referred to as lazy learning methods. So, instance-based learning, I'll use IBL for short. It's also known as what? IBL, instance-based learning. It's also known as lazy learning. Lazy learning methods, like some of you, huh? Okay, like some of you. Now you said you are lazy, you're not lazy, okay? But yeah, most of you try to procrastinate, right? So why is it called lazy methods? So instance-based learning methods are sometimes referred to as what? Lazy learning methods, because they delay processing until a new instance is classified. Now, if you get back to the definition, you see here instance-based learning. So learning that happens at a given instance. So meaning it has trained on the previous example. When a new example comes, it will not generalize. It waits again and does computation only when you have what? New instance that is to be classified. So irrespective of all you have done previously, when it cannot repeat the computation until you get a new instance. So that's why we refer it to as what? Lazy learning method. So what are the three types? So that leads us to what? Types of what? Instance-based learning methods. Okay. I use IBL for short. So why don't I put it here? So instance-based learning. So what are the three types quickly? The first one is called what? The nearest neighbor. The second one is what? Locally weighted linear regression. Locally weighted regression. And the third one is what? Case-based reasoning. Case-based reasoning. So when we hear of nearest neighbor, we say we use NN for short. Now when we hear of locally weighted regression, we use what? LWR. When you hear of case-based regression, you use what? CBR. So did I block the board? So three types exist, which are the nearest neighbor, the locally weighted what? Regression, and what? Case-based regression. So something case-based reasoning, I beg your pardon. So instance-based learning methods such as what? Locally weighted regression and nearest neighbor are used, or they are approaches which we use in approximating real valued or discrete valued target function. So by now, I believe you know what we mean by discrete valued and real valued target functions. Okay, we've studied those concepts previously. The advantage of this kind of delayed or lazy learning method is that instead of estimating the target function once for the entire space, this method estimates it locally and different for what? New instance, which must be classified. All right? So I'm speaking a little slow so to enable most of you to comprehend what I'm saying. Now, some definitions again. So whenever we talk of instance-based learning, we know that learning in these algorithms consists of simply storing the presented training data, such that when a new instance is encountered, sets of similarly related instances is retrieved or will be retrieved from memory, right? And those instances are used to classify the new instance query. Hence, instance-based learning approaches can construct a different approximation to the target function for each distinct query that must be classified. So these are some of the theoretical points of it, right? And then we now look into the advantages. So when we say what are the advantages now? We got the key idea, right? And then what are the advantages? So training is very fast, and it has the ability to learn complex target functions, and it doesn't lose information. So it keeps track of the previous training example state, right? Obviously, that's what we've seen. So if you summarize this now, we know that training is very fast. So the advantages, now let's write something down. So the first one, training is fast. Yes, why is training fast? You know the reason. Because computation happens only when the classification of new instance takes place. And it can also learn target function easily, right? And then it doesn't lose information. So learns target function easily. Or learns complex target function, right? So it learns what? Complex target functions. And the last one, it doesn't lose information, right? Ability to retain information. To retain information. So, I'll write it here. The third one is ability to retain information. Okay? Now with this, for every advantage, there will be some corresponding disadvantages. So for every merit, there definitely is going to be demerits. So what's the demerits? So the cost of classifying this instance can be high, obviously, right? And then, why can it be high? Because you know that nearly all computation takes place at the classification time, right? Rather than when the new training examples are first encountered.